Welcome back to G Fun Facts Online, the place where curiosity meets discovery. Today, we're diving deep, and I mean really deep, into a field that's getting a mind-blowing technological makeover. Imagine being able to uncover ancient secrets and lost civilizations without even breaking ground. Sounds like science fiction, right? Well, hold on to your headphones, because we're talking about the incredible world of quantum metrology and how it's revolutionizing archaeology. So what exactly is this quantum metrology we speak of? Think of it as archaeology supercharged by the weird and wonderful rules of quantum mechanics, the science of the supertiny, the atomic and subatomic levels. Archaeologists are now harnessing these principles to get unprecedented new ways to explore historical sites, analyze ancient artifacts, and piece together the grand tapestry of human history. This isn't a far-off dream. It's happening now, and it's poised to change everything we thought we knew about exploring the past. Let's start with one of the most exciting applications: peering beneath the sands, or a bustling city, or a dense forest, without disturbing a single thing. Traditional methods like ground-penetrating radar are great, but quantum sensors? They're taking subsurface imaging to a whole new dimension. First up, we have quantum gravity gradiometers. These aren't your average metal detectors. These remarkable devices measure incredibly tiny variations in Earth's gravitational field. Why is that useful? Well, buried structures, think ancient tombs, old foundations, or even compacted Earth from forgotten pathways, have different densities than the soil around them. This tiny density difference creates a gravitational anomaly, a whisper in the Earth's field, that these quantum gravity gradiometers can pick up with astonishing precision. Imagine mapping out an entire buried city, or pinpointing a hidden chamber before anyone even thinks about digging. In fact, this tech has already been used successfully to detect a buried tunnel. We're talking about potentially creating a Google Maps of the underground? How cool is that? This could dramatically speed up finding and mapping archaeological sites, saving immense time and resources. Then there are quantum magnetometers. These super-sensitive gadgets detect extremely subtle magnetic fields. Many human activities from the past, like firing pottery in kilns, building hearths, or even just digging ditches, altered the magnetic properties of the soil. Quantum magnetometers, some using fancy tech like nitrogen vacancy centers in diamonds or superconducting quantum interference devices, SKU-WIDS, are far more sensitive than older tools. This means they can find smaller, deeper, or more faintly magnetized features that would have been completely invisible before. We're talking about locating individual artifacts or even mapping vast archaeological landscapes. But it's not just about finding sites. Quantum metrology is also unlocking the secrets of the artifacts themselves, often without causing any damage at all, which is crucial when dealing with priceless, fragile objects. Imagine quantum-assisted artifact analysis. While some ideas are still speculative, like seeing into the past by reconstructing quantum states that interacted with historical objects, the more practical applications are already thrilling. Quantum scanners could probe the chemical composition and internal structure of things like pottery, bones, or ancient texts with microscopic detail. This could reveal faint, hidden inscriptions, secret layers of paint, or trace the origin of materials with unparalleled accuracy, all while keeping these precious items perfectly preserved. And then there are advanced imaging techniques. Quantum-enhanced imaging, possibly using entangled photons. Don't worry too much about the name. Just know it's super advanced. Can achieve much higher resolution and sensitivity. This could be amazing for looking inside archaeological remains, similar to medical imaging, or for finding hidden details within artifacts, kind of like a super-powered security scanner. Techniques like terahertz pulse imaging are already showing promise in examining culturally significant objects, like ancient Egyptian mummies and corroded metal artifacts, without unwrapping or damaging them. Of course, knowing when Tishmotus happened is fundamental to archaeology. While radiocarbon dating has been a game-changer, quantum metrology could help refine and even improve existing dating methods. The incredible precision of atomic clocks, themselves a product of quantum metrology, could be used to calibrate and enhance other dating techniques. Plus, the supersensitivity of quantum sensors might lead to more advanced forms of spectroscopy, letting scientists detect tiny differences in isotopic ratios or trace elements. These tiny clues could be crucial for dating materials or figuring out where they came from with even greater accuracy. Now, archaeology isn't just about digging, it's also about data. Lots and lots of data from 3D scans, remote sensing, and huge collections of artifacts. And this is where quantum computing enters the scene. Though still in its early days, quantum computing promises to revolutionize how archaeologists process and interpret all this information. Think about accelerated data interpretation. The massive parallel processing power of quantum computers could crunch through complex datasets at speeds we can only dream of with current computers. Imagine reconstructing 3D models of artifacts or entire sites from imaging data almost instantly. This could allow archaeologists to make better, faster decisions right there in the field during an excavation. Beyond that, quantum simulations could potentially recreate ancient environments with incredible accuracy. We could model past climates, landscape changes, and even the ecological dynamics of ancient civilizations. This could offer profound insights into how people lived, adapted, and interacted with their surroundings. And here's a fascinating one: deciphering lost languages. While not purely a quantum task, the ability of advanced algorithms, which could one day run on superfast quantum computers, to identify patterns and relationships in huge datasets, is already helping linguists crack ancient codes. This brings us to a more speculative, but incredibly thought-provoking idea: quantum archaeology and the concept of digital resurrection. This is an interdisciplinary idea that envisions using quantum computing, AI, and advanced sensing to not only reconstruct historical sites and events in stunning detail, but, in a more theoretical sense, to explore the possibility of digitally resurrecting past individuals or even entire civilizations by retrieving and reassembling lost information. It's way out there, sure, but the underlying idea that information might not be truly lost, just scrambled, is what fuels this futuristic vision. Now, as with any groundbreaking technology, there are challenges. Many quantum sensors are incredibly delicate and can be thrown off by environmental noise like vibrations, temperature changes, or electromagnetic interference. Researchers are working hard to make them more robust and field-ready. They also need to become smaller, more portable, and less expensive for widespread use. Plus, operating these high-tech devices and understanding their data often requires specialized knowledge, meaning physicists, engineers, and archaeologists need to team up. And the sheer volume of data these sensors will produce will require new ways to process and manage it all. Despite these hurdles, the future of quantum metrology and archaeology is incredibly bright. The UK National Quantum Technologies Programme, for example, sees archaeology as a key area for these new quantum sensors. Universities and research institutions are collaborating with industry partners to turn these lab breakthroughs into practical tools. Teams at places like the University of Birmingham have already successfully tested quantum gravity gradiometers outdoors, proving this tech can work in the real world. So what does this all mean? Quantum metrology is handing archaeologists a suite of transformative tools, from uncovering hidden cities without lifting a spade, to analyzing ancient artifacts with non-destructive precision, and processing vast datasets at lightning speed. This cutting-edge science is set to deepen our understanding of human history in ways we previously couldn't even imagine. As these technologies mature and become more accessible, get ready for a new wave of discoveries that will rewrite textbooks and bring the ancient world into sharper focus than ever before. The quantum realm, once just for theoretical physicists, is now unlocking the doors to our collective past, promising an exciting and revolutionary era for archaeology. That's all the time we have for today on G Fun Facts Online. I hope you're as amazed as I am by the potential of quantum archaeology. Join us next time for more fascinating facts and incredible stories from the world around us and beyond. Thanks for listening.